Hello, what's going on? It's Jun-chan, and let's shift the camera just a tiny bit. Yeah, welcome back. We're doing some Haskell and on the GPU using Accelerate, and we're actually doing that. It's been a lot of time where I've been saying that that's what we were doing, but given to technical difficulties, that's not what we've always been doing, meaning that sometimes we've just been trying to set things up to even run Haskell, trying to set things up to even run the Accelerate toolkit that we use, and then specifically the CUDA drivers that we need to use. But now finally we have gotten to the point where we can write some Haskell code. And when we looked at it 2 days ago, I just realized, well, it's been a while since I had been writing Haskell code. But not just that, it's also that I pretty much only once started to look into how to write Accelerate code, and I forgot what I learned. So that's where we'll start with today. We'll get back into understanding how Accelerate works. So let's pick some kind of tutorial, I would say. Maybe we're a bit ambitious and we start with the Accelerate repo and we look at the docs. I don't know why I said that was ambitious. And so that's papers. That's a simple example. How about that? That sounds lovely if it loads, and it does. Consider the computation of a dot product of 2 vectors of single precision floating port numbers. So we have a vector floats, another vector floats, and we fold them. And probably that's the Accelerate fold, and that's the Accelerate zip width. And so that does pairwise multiply and fold, but I suppose that instead of, we're in the ACK monad, and so all of these things are parallelized. So that's the main principle. Yeah, right, it creates a scalar. Okay, and check this out. Conversion, copying data directly between row pointers. Is that new? Okay, I'm getting distracted already. Version 1.3, no, it's not new. Okay, so that's a simple example, and then what? Accelerate, GitHub, So we need slightly more involved examples, and we're using one of those. And let's see, shall we just read some of the code of Accelerate again and try and understand from that? That might be just the best approach here. So let's go back into trying, and I think that's how I learned at least the little I know previously. So probably that makes sense to actually learn it that way again. I probably just remember some stuff. Okay, so main begin monitoring is just some incantation to be able to plug in, I think, EKG. Hey, would plug in EKG be a good idea, because that would give us some, because I want some performance data. You know what? I think that's a pretty good idea. Let's see, Accelerate EKG. Haskell. With any program utilizing EKG, blah blah. Enable EKG remote monitoring. Okay. It's doing, so that's by default enabled. Okay, hold on. Is it really by default enabled? I might have turned it off. Let's see. HLS, and let's do this. And we have our nice NBody simulation, and we go to localhost 8000, was it? Or 8080? 8000. Okay, so yeah, not enabled. So let's quit. and let's rebuild with the proper flag. So I assume there's a flag right here, EKG, default false. So I think we can just say plus EKG here and then rebuild. Cabal, let's build. Okay. And right, yes, it doesn't build because Barnes Hut is not in a shape to be built. So let's just do an undefined. Version and like so. And I didn't save it. Okay, and calc Excel's right. We need the int, and yeah, we just need the int. Okay. Okay, it's built. We run it, and we show it, and we reload, and it doesn't work. Why not? Is it trying HTTPS? No. Oh, do I need to start it with EKG? It's possible that there's a help. Criterion. Oh, no, but first to use in tests, so that's not it. JUnit XML summary, we don't care about that. So that's for tests, and that's for criterion. So why does it not work? Config. There's something about EKG here. There is not, but let's see. Let's check again that begin monitoring is EKG, because it could be that it's not. So how do I check that? I think I did a search on this previously. Accelerate debug begin monitoring. This will launch a server on the local machine at port 8000. Accelerate debug, but I suppose accelerate debug is not here. Okay, so not that debug. EKG, yeah, enable hooks for monitoring. There's more stuff that needs to be done. In order to view the metrics, your application will need to call data array accelerate debug begin monitoring before running any accelerate computation. Alternatively, if you wish to configure the EKG monitoring server, you can initialize it like so. Note that, as with any other program using EKG, in order to collect Haskell GC statistics, you may either run the program with blah or compiling with blah. I think that shouldn't be the problem, right? It should still work, I think. Let's, well, hold on, I'm not running it anymore. Boom. And boom. Yeah, it doesn't work, but let's see what our netstats say. Listening. And I mean, it's a little bit suspect the fact that it didn't pull in more, like it only recompiled accelerate. I would have imagined that maybe it would pull in like something for EKG itself. So let's change the default in the Cabal file. I mean, I'm pretty sure the Cabal project file is actually picked up, but yeah, better try again. Let's see if we Cabal build again, and it does say configuration changed. But no, actually, I think it detects no change. And so maybe I try to Cabal run instead also. Could it be that that this is not the correct build path? I mean, probably it is the correct build path. What is this X though? This new style, build, accelerate example. There it is, X. Don't know what the X means. Accelerate NBody, accelerate NBody. This is the one we are executing, I believe. Yeah. Okay, well, it's okay. We can run it with Cabal run, and maybe we do need to use the RTS flags. Okay, it's running in another window, but I can't connect to it. What could it be? What could it be? What could it be? Main. Begin monitoring. Internal.monitoring. Aha. Okay, so there's an indirection here. Lib internal monitoring. And if debug monitoring is enabled. Okay, well, there's a bunch of stuff surrounding this. So if def accelerate enable EKG, so is that the Cabal thing? That's just flag EKG. Is flag EKG, but probably flag EKG then define the -d thingy, but does it define it in all of the, it defines it for the library? Okay, so that's what we want actually. So presumably this is enabled, and also the RTS option is actually supposedly enabled here. It's also re-enabled for this example. Actually, it seems like pretty much each example, but let's make sure. Yeah, it is also enabled for us. Okay, so now what? Now we continue checking out what's there. We need debug.monitoring is enabled. Data array accelerate debug -f EKG. What's happening here? I wonder. The internal library should have been recompiled. Has it been recompiled? It doesn't seem like it has. So maybe I need to clean and then just run and see what gets rebuilt. it's not so smart for the flags. So, okay, rebuild CUDA. And look at that, it's not going to rebuild accelerate itself. Do we need? No, we don't need to have accelerate itself rebuilt. We only need the accelerate examples lib to be rebuilt. So maybe it's all fine, and maybe I didn't need to do that. Let's look at the issues. No issues here. Accelerate, EKG, not working. That's cool. Yeah. EKG monitor. Shall we just check out the EKG doc? Doesn't seem right. Sure know how to do that. EKG. Yeah. Okay, well, maybe that's for some other time then. I mean, let's see whether it works or not. It could be. I suppose I could also put some tracing statements in here. See which branch we're actually running here. We could do that. Maybe you want to do here. What am I doing here? I just want to put the line. Else. Okay, it will actually take some time to recompile. Okay, so that's one thing we can hold this lightly. Managing performance is something potentially for later. So here we're getting a bunch of numbers from the arguments. Yeah, the backend config. Then we create a random cloud of positions and a random or a uniform distribution of masses. And then we run the backend. Run being run being defined as internal backend. I see. Right, so that's the LLVM side of things. Okay, so it compiles again. At least that's it's a positive thing. And here we still do not have EKG. Okay, fine. Let's drop EKG on the floor for now, and let's continue with understanding accelerate. So we run the backend. Let's go take a quick look at this again. Run backend. So run takes a backend, and depending on, so it's an interpreter. Right, so either interpreter, CPU, or PTX. So we are using the PTX backend, which is the CUDA backend, and so it does PTX run. And PTX run. Well, I don't think we need to get into that, to be honest. So this is we don't need to get as low level. We can stay on the surface here. Right, so we run with okay, maybe we just want to look at what running is. Right, for example, using data accelerate LV and PTX run, it may be on the fly offloaded to GPU. Right, yeah, that's great. Okay, so maybe we do have to look at run. That's not, there's no usage here. It would probably be in the PTX thing. Maybe here. No, still more like building stuff. LVM, probably PTX, and I would imagine something like execute, right? Maybe we have run here. No, so maybe it's in the root. Yes. So it takes an ACK A and it returns an A. Cool. So yeah, and that's the ACK A. Okay. So that's the top level. I mean, no, that's not the top level. That's a computation, an accelerated computation that initializes bodies. And it's, I think, a one-off. It's not in the run loop. And it's set the start velocity using the start speed in the config. And okay, what does it do? Get config start speed, like that's the name of the thing. Constant probably makes it a scalar. Yeah, takes an E and makes it an EXPE. So yeah, I need to understand the difference between EXP and ACK. So something like run takes an ACK into an ACK of A into an A. Let's just try and find a tutorial. Haskell, yeah, sure. Examples, tutorials, mandible set. Maybe just documentation. How about that? Getting started guide. ACK. I want to know what EXP is. User guide. Accelerated language. That's going to be the docs. No, it's, well, I think it's extracted from the docs. But there we go. ACK represents embedded collective array operations. In terms of type ACK A is an accelerated program which, once executed, will produce a value of type A, consisting of one or more arrays. Collective operations of ACK A comprise many scalar expressions presented by the type EXP, which can be executed in parallel. I see. Okay, so actually I want to see the ACK monads constructors right now. And okay, maybe that would be in synopsis. Yes. Or not. ACK and source. Smart ACK, sugar array, blah. EXP is EXP smart exp LT blah. And smart ACK has pre-smart ACK, smart ACK, smart. So pre-smart ACK JDT that takes a smart ACK, which is a recursive bit, and an expression or a smart expression, which is one of these things. That's pretty involved, but it is what it is. Embedded expressions of the surface language. High-order abstract syntax expressions mirror the constructors of AST OpenEXP, but with the tag constructor instead of variables in the form of different indices. Type EXP represents embedded scalar expressions. The collective operations of accelerate ACK consist of many scalar expressions executed in data parallel. Note that scalar expressions can not initiate new collective operations. Doing so introduces nested data parallelism, which is difficult to execute efficiently on constrained hardware such as GPUs, and is thus currently unsupported. Interesting. Okay. So the fact that expressions themselves cannot be, or that there's one level of nesting, that you only have ACK and then it contains an EXP, but EXPs can't contain other EXPs. That's exactly the non-nested nature of things. Okay. And what else do we know from here? Although collective, oh, there we go. This stratification between scalar operations in EXP and collective operations in ACK help to statically exclude nested data parallelism. Okay, yeah, that's exactly what I was saying, so that's good. Which is difficult to execute efficiently on constrained hardware. Okay, but better written, better said. For example, to compute a vector dot product, we can write blah, vector A, ACK scalar A. Hold on, is it? But didn't we have vectors of XP in the other example? I think we did. Simple example. Ah no, ACK of vector floats. Okay, well, I'm confused right away. Okay, I kind of had the instinct to, first I had the instinct I wanted to fire up a GHCI. Maybe we can fire up GHCI. Move you here. No, that's not going to work very well. Let's move you. Let's move you here. And yeah, let's, what would it be? Cabal REPL. Yeah. And then we'd import data.array.accelerate as A. Then we import I think what qualified prelude P. We're not even using P there. So and then we need to do the multi-line thing. Does that even work already? Okay, like this. Yeah. And then we copy that and see whether it works or not. Okay, need to use the proper copying, and then like that, and then like that. No. Blah blah. Well, hold on. Am I? Oh yeah, no. Okay, okay. I see. That was in that direction. So, of course, it's not gonna work. So we do it again and insert and like so. And okay, so we do need to be qualified. Okay, fine. Or import no, we'll do we want a.num? I think we do want a.num. So okay, so we'll do it again, but let's say a.num, and then we'll put the rest, and up to zip width, which we want to prefix with a dot. Oh no, so made a mistake. This is okay. And I can't copy this sanely. No, I can't. And I made a mistake again. Okay. Here. Here. Breathe. Okay. Certain amount of struggling right here, but nothing too bad, hopefully. Okay. There we go. And we're careful here. And blah, blah, blah. Okay. Non-type variable. Use flexible context to permit this. Okay, what's going on here? Why do you bring expa here? Is it because you think a is expa? Or something else? I mean, could it be that this is this hasn't been updated and that I should look instead at the package? That's possible, very possible, in fact. Yeah, we don't need the linear thing, and package and accelerate and this guy. And that looks the same. But let's assume that this is more up to date. It's probably the same, but okay, well, let's just use flexible context. So how do we do that? We do set -x flexible contexts, and then we gotta rerun the thing, but I suppose we can do it like so. Just a bit ridiculous, but oh well. Sometimes we gotta be a little bit ridiculous. It's fine. And there we go. Okay, well, now it seems like it works. So now we do .p of what? Can we construct a vector? Like so, we want to construct a vector. Well, let's look at the vector type. Boom, boom. Is vector only in linear. I think it is only in linear accelerate. Okay, and I closed it just now. It's fine. Okay, give me the package, please, and give me vector, and help me figure out how to construct one, and so is vector a superclass of all of these things? This is additive. Where is vector defined? Not here. Is it just the linear? It's probably just the vector from linear. Makes sense. Oh, well, more vector from vector? Maybe, I don't know actually. Probably vector from linear. Not linear dash. I assume, right? Okay, let's also get linear accelerate. It depends on linear, yes. So yeah, it should be the vector from linear. And hello vector from linear, we've seen this before, but okay, is it just is linear using vector from vector? It is. Okay, I see. And so what is data vector? It's just box vectors. And what's the constructor? Vector, an int, and an array. So how do we build one? Let's, oh, numeric Haskell vector tutorial. Generating vectors. From list blah. Works for me. From list 1, 2, 3. From list 2, 3, 4. And dot product should be multiplication of the thing pairwise and the sum of the thing. So you know what, let's do something simpler. 1, 1, 1. So this should be 6. Do you want to type? Maybe you want to type. You want vector of int or something. Is that gonna work? Well, you have vector of ints here. What's the problem? From this is applied to too few arguments. Is it? Do I want 8 on? Maybe I'm using the wrong from list. Yeah, that looks like the accelerate from list. I want the data vector from list. So data.vector.from list, is that a thing? Can we get one? We're not in, okay. Import data.vector as v, how about that? We're not actually importing vector directly. Isn't that re-exported? How? That okay. Do I need to import this? Is there a from list here? There isn't. I mean, not in here at least, but how about here in linear? There's all these things. V1. So maybe I should just do a V3 1, 2, 3 and call it a day. That might be that might be the way. v3 underscore. Apparently you need to specify the type. v3 underscore as opposed to v3. Is it me or this documentation like really not easy? Okay, this takes, it's a pattern. It takes 3 exps and create an exp of v3. Okay. Whereas v3 is just that thing. Okay, so let's just try to pass it v3s because we're supposed to have a something that goes from vector to vector. So let's try and pass it v3s of 111 and let's try and see what it says without the annotations. And we have some type problems because we have type variables that are ambiguous. Okay, fine, we'll tell you that those are ints. And we don't have v3 as a type, so we import what is it, data dot accelerate dot linear dot vector dot v3, and we import v3. Data array. A hidden package. Really? Fine. In that case, we shall add a few things to the build depends in our cabal file because we want to be playing with these things here. So linear accelerate, and hold on, that's supposed to be okay. So do I need to target? Do I need to cabal, REPL, accelerate, NBody? Is that the errors of my ways? Sort of, but apparently the problem with preprocessing. Okay, well, let's see whether we can import this guy. We can. Good. Well, then in that case, we set flexible contexts, and we actually also need to do the other imports. Not list try. Oh wow, it kept that data vector. No, accelerate as a yes, and then we redo the dance with num. That's what we want. Dot p that guy, and you know what? I need to just go back here. Let x is that right? Yes, x is prime. So y is prime in, and what's the other one? It's fold. Boom and boom. Yes, and then dot p of this. Oh, are you kidding me? So v3 was available from data accelerate, data array accelerate. Okay, I think it's possible to unimport. How do we do that? Is it unset or module minus maybe? I think it was module minus. Maybe undef. Load module independent. And add remove module from the target set. Let's try an add. Data array accelerate linear v3. Okay, fine. And yeah, and then we don't need to do that, I don't think. Okay, I really should have this thing ready to copy paste somewhere else, but I guess now it's not too far in my history. Yes, this we import, then this and this, and I forgot the type signature. Okay. And okay, well, I have no idea why. Okay, and yeah, replace all, and then we can deal with that manually. Ah, that's not pleasant, huh? Okay, and so we do this and that, and okay, yeah, fine. So therefore we do that, and then we do r.p. But then we say a.v3. That's right. Okay, hold on. Is it this then? It is not. Browse A. Browse data.accelerate data.array accelerate. That's going to be too many things. Okay, what did the error message say? The error message is gone. It's not, it's here. Ambiguous occurrence v3. Can we put refer to either a.v3? So there is an a.v3 or data accelerate linear.v3. So are we talking about the same thing? I mean, it could be also that we're not talking about the same thing, which would suck. Data accelerate vector. CMD vectors. Yeah, vectors. That's not. We don't know what vector they mean. Data accelerate vector. Array dim1. Yeah, that's a different vector. That's a totally different vector. And it's also a different array, right? It's just a partially applied, yeah. It's the shape, and then E is just the element type or array elements, and array elements. What are they like? Why isn't there like just basic documentation on how to create a vector? Okay, maybe I'm not, maybe I should just look at the code and there's some example in there. I'm not thinking properly. Vector type. So actually this uses linear. But the dot product example doesn't. Okay. Okay, so that's shapes. That's fine, but then elements, simple atomic types. Arrays, array. E represents the type of each element of the array, for instance, int, float, etc. It doesn't tell me how I construct it. Section getting data for getting in and out. Okay, getting data in lists functions. Getting data in lists. It's just from list, but it takes a shape. And the shape needs to be passed in. Okay, all right. Okay, I think I get it now. Okay, so where do I get? I get that we do, right, so here we have vectors and they're not linear. So we do from list, but we pass the shape because it's an a dot from list. And the shape is what? It's dim1, so it's actually something like, well, it's actually 3.z, or is it reversed? Why is this not showing things anymore? List, it's z blah 2 0 1 2 no 3, and then 1 1 1, and then a dot from list z3, and I have a good feeling about this. Defaulting to, oh, okay, what? Oh, well, it's interesting that it shows color in GCI. I think that's because that must be the show instance of a ACK thing, but we need to run it with the backend, and the backend is PTX. None of that is in scope. Let's see. Let's look at main again. Our main poof run backend. Where does run come from? Maybe. Okay, let's hover over it. Blah, run. Internal backend. That area. Yes. And so we do have to import that crazy thing. Fine, let's do so. Let's import it qualified. We say import blah as b, and then we b.run b.ptx, I think. Yeah, Oh, we could b.ptx.run maybe directly, but no, actually, I presume we can't. Is that? Yeah, I think that's probably fine. And then we pass it this. How about that? Hey, scalar z6. Ta-da! We ran a thing on the GPU. I mean, something we wrote. Well, from the example, but and right. So you'd feel better with a type annotation. We can give that to you by saying vector int, I believe. Yes. Good, good, good. Okay, I'll take a little break and we'll be back. Okay, so we did run a ACK expression into the LLVM-PTX backend. That's great. By the way, can we run it into the CPU? b.cpu. I think, yeah, it is not in scope because we don't have the native backend enabled, I think. But interp should be, so that should be slow, but we should obviously not see a difference here. But that's not even in scope either. Our interpreter. Okay, good. So yeah, that works. CPU is not, we haven't compiled the native backend, but this works. Good. So, okay, so then the natural follow-up question here is how come we go from vector A to ACK scalar A? Why don't we have an EXP of vector A? And so another question related to that is, what is the type of zip width? So let's answer some of these questions. A.zip width. So that's supposed to take, it takes plus, which operates on expressions, and then to accelerate array of shape A. So vector is an array of shape A. So maybe automatically we put it in pure. No, we use use, and use must be the thing that the use function, they're embedded with the use function. Page not found. Okay, use a.use. Yes, what's your type? Arrays to ACK arrays. Okay, so it all makes sense. This is really an EXP vector A. No, hold on, what am I saying? It puts it in ACK, not in EXP. Zip width. Zip width takes an ACK. Okay, so we're fine with zip width taking an ACK, but we pass it a function that takes EXPs, and I suppose that type of A.plus is EXPs. That's just that we have a num instance for vectors, so it doesn't matter. Or actually a num instance for expressions. And I suppose expressions is where this it's the elements. Actually, the elements here are going to be expressions, because that's pointwise that this is applied. So in this case, we can say EXP is inside the type of the element inside of the array. I think that makes sense. And yes, indeed, because we have array A with A an element, and then we do EXP of A. So meaning, for instance, int, an array of dimension 1 of int, such that we have int elements and then an EXP of int, and EXP of int, I would assume, is just a wrapped int. Okay. Let's continue reading. Function.p consumes two one-dimensional arrays of values and produces a single scalar result wrapped in the type ACK. We see that it's an embedded accelerated computation. It will be evaluated in the object language of dynamically generated parallel code rather than the meta language of vanilla Haskell. Sure. Yeah. As the argument to .p are plain Haskell arrays to make these available to, well, plain Haskell arrays. They're not exactly plain Haskell arrays. Vectors are these dim thingies. What am I doing? Yeah, info. Yes, that's right. Yeah, vectors they're not typical arrays. They're actually 8R arrays, right? And 8R arrays are this. So why are you saying that these are plain Haskell arrays? I mean, maybe under the hood, these actually do become plain arrays. I suppose that might be the case. Yes. Okay. An accelerated backend is used to evaluate the embedded computation. Yeah, and return the value. Okay, yes. Calling the run function at backend will generate code for the target architecture, compile it, and execute it. Yes. Right, so that's hidden side effects there, which we might care about at some point, but way in the future, if we want to sort of take into account the compilation time. I mean, yeah, I'm interested in understanding how we can minimize the time to pass arrays from RAM and allow them to be computed in the GPU. It could even be that that's done through shared memory, like on the PCI bus or something. But I don't know how to, if it's even possible to specify these things here. So it'd be interesting to, I don't know whether that's the main thing that I want to explore here. Let me think a little bit about it, because now I'm taking a bit of a step back and thinking about why I'm doing this experiment. One of the ways in which we'll be trying to do zero copy pipelines is in GStreamer. So in that case, we don't really need to be caring about doing GPU manipulations of that sort. So, but it's not impossible that we would have a GStreamer element which we try to write in Haskell. That could be what? Like one thing that it could be is a source of graphics, for instance. That's one of the things that interests me, because I'd like to be able to specify graphics in Haskell. So if it's a source, then either, so there's a potential for it to be, well, if it's a source and it's actually tied to the GPU, then I wonder then if it could be something that lives. Can you have a GST element? I think you have GST elements that live in the GPU, right? GST element GPU. GST CUDA. GST element sec fault. I think that the GL the GL thing is, yeah, GST GL image sync and so on, GST GL effects. Yeah, so that's the guys I think I'm looking for. And can we do something like a GST, where first of all, yeah, would it be GST GL? Can we even, how would it work? Once, could we run several things in the GPU in parallel? Does that even mean anything? Or does, yeah, basically, is there a shared execution model for GPUs or not? I don't even know that. GL source bin, infrastructure to process GL textures. Right, so a possibility would be, like, let's say that we have a shared execution model, that we have GST that's able to, for instance, has a GL source bin. Where would that be? Where does that take? Infrastructure to process GL. It takes, it outputs a pad. I mean, it has an output pad, but then just a pointer? Is that what it is? Just a pointer, no shape? Or is that the shape? Create element callback. No, that's just a callback. Will be emitted when we need the processing element that this bin will use. Ah, okay. So this would call our Haskell program. And then our Haskell program would provide a texture at some pointer. It wouldn't exactly work like that, but run last. But okay, if we go back a sec from this specific implementation method, what I would think is that we have a Gst pipeline, take some live inputs and whatnot, has a part that's in the GPU, maybe to do 3D transforms or compositing, and then also has a source that is actually a GPU source, so maybe the the GLSRC bin that's connected to, let's say, some area of memory of the GPU in which a Haskell program is writing some 3D shapes. And in fact, there would be some kind of pool, because that create element callback then will be emitted when we need the processing element that this bin will use. The processing element. It could be that that's just downstream. It's just a create element callback. It's a signal that gets emitted when the element is created. So maybe I'm just confused there. There's no pooling or whatever. It's just the source is just, I don't know how the source is specified. I don't know how you say which texture this is going to be getting anything from. What's a GL filter app? Resize and redraw callback can be set from a client code. That has a sink and a source. So it could be something like that too. Will be emitted before to draw the texture. The client should redraw the surface content with the texture width and height. So is that a callback mechanism also to provide the sync frame to some third-party thing that would then just write back, and then that would be emitted in source? I mean, it kind of makes sense. And then sources would be like that. Let's look, and then sources then yeah, would be called to provide frames, maybe. UData has no description available. That's sad. Let's look at sync. What does sync say? GL sync bin. Oh. Oh, okay. Oh. Wow, there are tons of things in the sync. So a GL sync, I imagine, could be, yeah, it could just be like a window with different things. It can be in GL memory or DMBuff or system memory. So maybe that's the shared memory. Video GL texture upload meta. Meta Gst video overlay composition. Okay, well, I don't know enough about OpenGL to be able to understand what this is. So we need to figure that out. But I need to think also, is this really the use case that I'm looking at? Like Haskell as a 3D generator? I need to look a little bit more into my my notes for the NBody tool. Physics simulation, streaming abstractions, low-level efficient data flow programs. Then maybe nested data parallelism and data parallel Haskell. Oh, layout algorithm. Yeah. Yeah. And so then I suppose we're also interested in something like fear. The EDSL compiling to Spear V, which should allow us to do Vulkan programming. Hop vibration. Okay, no hot reloading. So this is just shader compilation though, but from Haskell. So would that be sufficient to do layout algorithm? I don't know, because layout feels like a bit like GPU. But it depends. If we want to make this part of a GStreamer pipeline, which I suppose this is kind of what I want, don't I? It's kind of what I want, but I'm also interested in just raw, like hooking into desktop compositing layer as well. So like something like Wayland, right? And like the Wayland Vulkan path. If there is a Wayland Vulkan path, then can I hook into this with shaders, or do I need to hook into this with? Can I hook into this even? Is it possible to hook into this via GStreamer pipeline? Let's look at the GStreamer Vulkan stuff. I think there were a couple of things there. I think it's very new, but there's at least a sync, but there's no source. So that's not gonna help. So data uploader, that's a video sync. It's based on OpenGL. And just a Vulkan image. So it takes the Vulkan image and then maybe it pipes it to an OpenGL video thingy. A view convert. I mean, this is super bleeding edge. There's really not much in here. And let's take a look. It's too bad that there's no link to the code here. Okay, GStreamer, GitLab, and it's actually free desktop. That's documentation, and that as well. And Vulkan lib, probably, maybe. Oh, there's more stuff here, but is that, maybe that's underneath? Oh, Vulkan Wayland library. Oh, we're not in GStreamer anymore, but we are though. Hold on, what? GSTVK display Wayland. So there is a GStreamer Vulkan display Wayland. So what I was saying actually exists. I mean, I don't know in which direction, but probably the sync direction. So probably I don't even know enough about Wayland, to be honest. But then maybe we can, so can we give, okay, I want to know a little bit more about Wayland now. Wayland compositor, is it a compositor first of all? A display server using the Wayland protocol is called a Wayland compositor because it additionally performs the task of a compositing window manager. So yeah, it's correct to see it as a compositor. Okay, let's take a look at the architecture. Yeah, that was back in the days, and now instead we have Wayland clients, which are things like what? Presumably applications, and then the compositor is the thing that looks through its scene graph to determine which window should receive the event. Okay, hold on. Kernel gets an event. I suppose that's because it needs to deal with the input layer, so keyboard and mouse and whatnot. So gets an event, send it to compositor, similar to the X case, which is great since we get to use all the input drivers in the kernel. Yeah, that's right. That's for input drivers. Compositor looks through the scene graph to determine which window should receive the event. Okay, so that's that's fairly traditional, but that's definitely where I want to hook. What I want to hook into. I suppose then the question is there a Wayland 3D compositor? Are there several compositor backends? 3D Wayland compositor, Wayfire 3D Wayland compositor. Spyback comp is based on WR roots. What's WR roots? I say it like I know it, but I don't. A modular Wayland compositor library. Okay. Pluggable, composable, unopinionated module for building a Wayland compositor. Or about 50,000 lines of code you were going to write anyway. Backends that abstract and allowing display input hardware, putting all this blah blah, plus custom backends. Mostly standard implementation of many Wayland interfaces. Protocol extensions, promote standardization of portable extensions. Several powerful standalone optional tools that implement component comment compositors. Okay, let's see if there's any Haskell Wayland things. Not Waylands. There is a thing apparently. It's deprecated, but let's look at it. He's not happy with the bindings. Oh, new Haskell Wayland interface. That sounds good. Sudbury, okay. 4 years ago. Haskell implementation of the Wayland protocol. Any implementation of the Wayland protocol needs to support some C ABI calls if it wants to support EGL. Isn't EGL the NVIDIA thing? Like the streamings thingy? Maybe not. Okay, that's EGL. No, so that's the open version, I think, of what NVIDIA has as streams. Maybe. There's something as an EGL stream, and NVIDIA Media EGL stream is a thing. And NVIDIA can consume EGL streams. So it is about streams and it's somehow connected to NVIDIA, but it's also standardized. Handles graphic context management, surface buffer binding, rendering synchronization, high performance accelerated mixed mode, 2D and 3D rendering. Yeah, hold on. Let me pause for a second and put some socks on. And all nice and warm. Okay. What was I saying? EGL. Yeah, that's a bit of a... Yeah, I'm definitely zooming out here because I want to go back to why I'm thinking about Haskell on the GPU and inch towards learning more about some of the things that I want to interface these bits with. So we definitely go back to using accelerate and play with it. Also on the visualization side and the 3D rendering side, definitely want to continue playing with that. But I also want to see how I'm going to hook up into things like Vulkan and Wayland, because I'm interested in seeing how low I can get at the close to the graphics layer of the operating system to do things like layouts in particular. So I'm gonna write these things down. This is interesting. I want to take a look at it. We just aim to implement the entire C ABI. Where's the sample code? At this stage, most work has gone to preliminaries and supporting the C client ABI. That means that this is a piece of really elegant Haskell code that can only really be used by C Wayland clients. In other words, this project currently a drop-in replacement of libwayland client.so. Always client seems to run correctly. However, the aim is to write a really nice Haskell interface so that you can write all your Wayland program in elegant Haskell. See issue number 2 for usability of this code in Haskell. See issue number 3 for progress on the CABI for compositors. Making this a drop-in replacement of libwayland server.so, thus a replacement of the original C Wayland code. Thank you. This won't change. This won't work because the libwayland C library assume it's in charge. Oh, what? Okay. This library builds its own dynamic object. If you have a piece of C code which calls into C libwayland code, doesn't do e.g. hacky pointer arithmetic, then it will work equally well with Sudbury. If not, so that's a complete replacement. What a heroic thing to do, but it's obviously probably a bit rot, unfortunately. But wow, what an undertaking. And let's look at the issues. Is this project dead? Let's also look at that. Oh, something aggressive about the question. What am I as an author supposed to do with a project that I'm currently not working on? I think you just like to know if you have any plans for the project in the future. That makes sense. Translation. Okay, that's interesting. Personally planning to. Not personally planning to continue development, not putting bread on the table, not publishing papers. I had a project because I wanted to know how far I could push the idea of systems programming in a lazy functional setting, and to a large extent this scope was fulfilled. No immediate use case for this project at the moment. However, I believe there is a gap in the market to be filled by something such as this project, namely a binary compatible alternative implementation of the Wayland protocol that allows lower level access to the protocol. Such lower level access can be used to analyze and stress test the Wayland protocol. Okay. That's not what I'm interested in. I'm not sure if this would necessarily need to be written in Haskell, although it's very satisfying to see that it's possible in principle. Of course, there's a prospect of a Haskell-based compositors akin to Xmonad. Okay, so that's more like what I'm interested in. But I don't think there's a watertight argument for using Haskell and library dependencies there. If you're writing ordinary Wayland software in Haskell, your Windows clients or graphical compositors connected to display, probably makes sense to FFI to existing high-level Wayland libraries. Yes. So, or in other terms, Sudbury might be too low level, like trying to re-implement the Wayland side of the compositor might not be a good idea. It might be better to use like maybe WL roots, FFI to WL roots basically, or maybe even FFI to Wayfire if that even is a thing. So let's see if those things are things. Haskell WL roots, how about that? Ta-da! Indeed there is. And that's a bit old as well, unfortunately, but less so. And then tinywl. That's less Haskell Mac Wayface. Oh boy. Okay, this is not even clear whether that would work. Oh, it's in SimilarVR though. So SimilarVR is very interesting because that's not very far from the type of stuff I'm interested in, because I am kind of gearing towards VR or AR as potential targets there. GDWR roots. What's that? Yeah, Godot module providing bindings to WR roots. Because Similar, in the end, I think it actually ended up. There's also Haskell Wayland, so definitely in the, and then Haskell Mac Wayface. Also, Mac Wayface is actually a thing that exists in WR roots. I see. Let's look at what that is. Mac Wayface. Love that thing. Demonstration Wayland compositor accompanies a series of blog posts. Okay, let me check out this blog post. Wayface. No. Okay, WL roots. Yes. Writing Wayland compositor. Hello WL roots. Probably that thing. So it's kind of a hello world, I think. Okay. So the good thing is we don't need to go that way down. Rendering a window. What's that? Yeah, we don't need to go that way down because other people have done it with us, including yeah, those higher level bindings and this. So is this binding to the original Mac Wayface thing, or is it? No, it's not. It's actually, it's binding to WR roots implementation. So okay, that's WR roots, but so it must be using the Haskell. Yeah, this guy, the HS roots, right? Which is also here, isn't it? No. Here, HS roots, Haskell binding to WR roots. So let's see this source, graphics, Wayland. Yes, so that's indeed is the correct namespace there for what we were seeing here. So that sounds like that's the kind of tooling that we would want, and unfortunately, or maybe fortunately, not that. And that is not clear how. Hey, Nini 420. I'm very good, thank you. How are you? I am, yeah, I've been making some good progress with my running the NBody simulation in Haskell, and I can show you like some pretty have some pretty things to show for it. And so now I'm kind of taking a little step back and thinking, why did I want to do that in the first place? So that's where you catch me, and I'm also sort of preparing to wind down pretty soon. But so this is a physics NBody simulation, and it's running in the GPU, and it's using a naive algorithm. So it's a ON square algorithm. There's a more advanced algorithm, and I'm actually interested in implementing the more advanced algorithm. But I'm also interested in just doing functional programming on the GPU and understanding how we can make use of that computing power using functional programming. And so now I'm kind of zooming back and thinking, okay, where would I see this kind of GPU programming fit inside a kind of maybe more ambitious project that I have in my mind? Cool. So do you program yourself? What brings you to these parts of the internet? Yeah, so the Mac Wayface might be an example. So we probably want to look at that code at some point. So learn about Wayland 3D compositing. And so for that we'll look at this, and then we'll probably also then look at the HS root. Yeah, this guy. and then we want to look at just generally 3D compositing in Wayland, for instance, with something such as Wayfire. And because then I suppose, I mean, I don't know, I suppose maybe Wayfire would be the thing that does GPU calls, whereas Wayland just is just like the pass through for the input and the output. I don't know. Don't understand these things very well yet. And yeah, let's see. Wayfire dependencies depends on a whole bunch of things, including libgl, which goes in the direction that maybe I'm right about the architecture here. So let's look at the architecture diagram once again. So I suppose a Wayland compositor is something that talks the Wayland protocol using 1 and 4 then, or is 2 and 3 the place? Maybe Wayland protocol is in both directions. Maybe it is. So the compositor needs to to properly respond to Wayland client calls, and then has control over how it's going to talk to the GPU. Haskell looks complicated. Haskell is it's its own thing for sure. If you've never seen Haskell before, then it's definitely a whole other world. And you know, the first time I encountered it, I was like, I can't understand this. This is strange. And you know, it's strange. And also, I was encountering it after 20 years of doing software engineering, and I had this idea that picking up a new language was, you know, just learning new syntax, right? And maybe some differences in some low-level stuff. But Haskell, I was like, I don't understand what the hell this is. And this was maybe 5 or 6 years ago now. And at first I bounced off it, and you know, for a month or two maybe I didn't look at it, and then it was in the back of my mind, and I was like, okay, I do need to look at this, because there was this promise of, well, it's more elegant, it's concise, you can think more in mathematical ways, it solves like hard problems in a better way. And so all of these sirens kind of attracted me to actually look at it again. And then you know, I looked up books and started from the beginning. It's like, it's a hard process to start from the beginning, you know. It takes a bit of patience. And now I suppose 6 years later, I'm like intermediate level, and I'm kind of like starting to try to do more advanced things. And I suppose that's a bit what these streams are about. It's me filling my gaps in my intermediate level, and then also trying to learn more advanced stuff. But yeah, I hear you. Haskell looks complicated. Haskell looks like it's written by aliens. It's a weird thing. I totally agree. Yes. So, right. So if a compositor such as Wayfire sits in here and understands, because it understands Wayland compositor, is able to speak to Wayland clients, and then also speaks to EVDev and KMS, then I suppose it's doing something like sending like those 3D frames to KMS, maybe. Wow, indeed. Tell me a bit about what you're up to in the programming world. What are you a programmer? Are you a student? What's your favorite language so far? Yeah, so that Wayfire thing sounds exciting. And is it maintained? It is pretty actively maintained, actually. Let's look at the website. Yeah, let's look at a video, because it's a 3D compositor. It must be pretty to look at, right? Okay, I need to undock that window in order to play it full screen on the screen. Okay, yeah, it's like Compiz. It's okay, flaming logos and cubes. Okay, yeah, I mean, I suppose that's what I don't want to be mean, but I suppose that's what programmers do with 3D capabilities. They do cubes and they try to make it run fast, and they do flaming windows. Yeah, and like pretty backgrounds. Okay, yeah, definitely like not game quality, right? But it works technically. Clearly, it looks really fast, and obviously your windows are displayed in it. So it's obviously, for me, it's the right stack. It's the right toolbox that I want to build upon. Started web development 7 months back after completing my college, where I learned nothing. Yeah, I mean, I learned something completely different in college myself. So, you know, good for you. Studied web development. That's awesome. That's exactly how I started as well. Did HTML, CSS at the beginning, and then started doing server-side stuff. Did a bit of ASP, PHP, and content management systems, and you know, took me a while to get to Haskell. All right, yeah, and you know, I still do quite a bit of JavaScript as well. I mean, these days I do mostly pure script, which compiles to JavaScript and is a bit like Haskell. It's in fact very much like Haskell, but it can run in the browser, therefore it can run in Node, and it can interface with React. And I've done quite a bit of React and React Native as well. So completely understand your stack. And the reason why I went into functional programming languages is because I was trying to write more complex, rich client interface, I suppose you could say, right, in the browser. And it just felt that it was like a lot of reinventing the wheel, that there was like web components also and React also. And it just felt like there was a lot of just noise and complexity that didn't feel elegant. And that's what led me to think that I can't believe that, you know, where at the time we were in like maybe 2015 or something, or maybe a little bit later. I can't believe that we're, you know, well into the 21st century, and that it feels like such a weird DIY like glue and nails and, you know, like weird like assembly of what seemed to be inelegant pieces together in order to build like interesting web experiences. And sure, like, you know, React and all of this, it seems like those are more elegant frameworks, and with Redux and like state management, it seems like these things seems like maybe they can become a little bit more easy to think about. But that's really what was my gateway into functional programming, because then I discovered that for a while there's been some more principled approach, more elegant approaches to think about this type of problems of like complex UIs, and that in fact then you start seeing that React and Redux is actually pretty much a reinventions of concepts that existed for way back in computer science, and especially inside those functional programming languages. And that's how I got hooked. I started listening to some people that did JavaScript in a functional style, and then these people were talking highly about Haskell, and then, you know, that's when I looked at it the first time, and then I was like, oh my god, this thing is weird. I don't understand it at all. How come after 20 years of doing software engineering, there's a programming language I don't understand? What the hell? Where is this thing? What is that thing? And then the promise was too big, and to be honest, it's paying off, except it takes a long time to pay off. But you're younger than me, so you can probably pick it up much faster. I'm assuming there, but anyway, I love that stuff. And therefore, I'm trying to, you know, sprinkle it in pretty much everything. And so right now I'm thinking about operating system level windowing and compositing, and seeing how I can sprinkle some Haskell there. And gladly, I am not the only crazy person attempting something like this, because these guys from Simula VR are using Haskell to bring a Linux desktop experience to VR and AR, which is close to the direction that I want to get into. So, and yeah, Simula is mostly written in Haskell, but it uses Godot, the 3D rendering engine, as its rendering layer. And I think that's pretty smart. And I should definitely pay more attention to what's going on here, including the fact that maybe I should build it and play with it. I want to see whether there's some kind of way to interface Godot and GStreamer. Integrate video saving with GStreamer. Godot only needs to send the stream to GStreamer, which maybe can be done through a GStreamer plugin in Godot. Yes. Okay, let's see. Let's see what the people say at the end. Job for a third-party C++ module or GD native add-on. There hasn't been much support of it. Okay. Yeah, most car industry uses GStreamer for cross-media. And NVIDIA also plugs into it for, yeah, indeed. It's not a problem, the GStreamer itself is GPL. Okay. GStreamer plugin. Oh, did you say, come on, that you're being nice. I appreciate it. Thank you. Well, seize the opportunity and ask me some questions if you have some questions. Starting to make an landing page for my website. Hey, you know, that's how I started. Keep going at it. You know, the only way to get better is to stay focused, keep trying until it works. And then, you know, after your 10th landing page, you'll feel like, you know, your first was hard, but now it's easy, and you'll be moving on to greener pastures. So keep at it. It's really the secrets in life. It's also good to sprinkle a little bit of, you know, fun and diversity of interests, because otherwise keeping at it becomes boring. But keeping at it is really what yields results. Okay, element source. Okay. Many ways to be done are possible for this. Okay, an example source plugin can be taken as a reference. Plugin name. This one takes an OpenGL context and send the frame into GStreamer. Yeah, so, okay, basically, I mean, unless there's a standard way in which Godot could export, then we're back also at this question of, can we do things like shared GPU usage, where Godot uses GPU and we'll be like, hey, let me use this frame there. I really wonder whether that's possible. I suspect, I mean, it is a security, it sounds like it would be a security issue. AppSRC. I think it should, because it's the way to go. Creates frames, sends them into GStreamer. Yeah. What's AppSRC? Can be used by applications to insert data into GStreamer pipeline. Yeah, it's exactly what's needed, actually. Well, no, it's not necessarily, because this might mean it doesn't mean that you can inject it directly into the GPU, for instance. Yeah, I don't know exactly how that would work. I do not know, but that's interesting. I mean, and you know, maybe Simula does it on Godot, and maybe I'm trying a different route. I mean, I like the idea of having a 3D engine, to be honest, but especially with all of the. This is an X Wayland branch. Oh, no, but I'm not in Simula here. I'm in GD. Similar here, yeah. yeah, obviously using what is this? Ah, right, it's a nice fonts filter. Okay. Yeah. Yeah, right. Godot gives you OpenXR, and so you don't have to like all of the VR thing can be done that way. That's obviously a huge thing for all the 3D transforms that will go with it, and it also is compatible with Steam VR. Yeah. So that's why it's the right choice for them. And if I target VR and AR as well, then is it the right choice for me? And should I just join forces? It's very possible. But I suppose I'm also interested in kind of a migration path where actually we can do... I mean, is this... This is not a Wayland compositor, is it? Or is it? Mouse and keyboard view. What's up with visit our website? FAQ. Similar OS. Yeah. Developer resources. Yeah, so let's see Wayland. What are you doing with Wayland exactly? Ah, you're using it as a backend for Godot. That's probably what's going on. Let's check it out. Godot Wayland. Godot's position on Wayland. What does that mean? Wayland is a protocol for compositor to execute client, blah. They want to ask these questions there. Can understand. Okay. Working towards native Wayland 29. Okay. And oh yes. No. On top of all the Godot happening for its Vulkan rendering support, the code base for Godot 4 is also being cleaned up, and among other improvements being worked on are Wayland and UGL support. Juan Linetsky provided a first update on the state of Godot code refactoring. Besides a lot of low-level code improvement, looking ahead of March is working on implementation for Wayland and Next CGL. On the blog, okay, let's check this out. Code refactoring, February, and that was more than a year ago. So you can imagine that the Wayland stuff is much better by now. So let's go check out features there. And yeah, that's really way Wayland's not listed in there. Let's go to is that the GitHub thing? No. Go to GitHub, and yeah, is there Wayland here? No. How about in there? So we can infer through this issue that actually Vulkan Godot works on Wayland. So yeah, that would be quite nice. But it wouldn't fulfill my multimedia streaming pipeline views. But maybe that wouldn't be a problem, because maybe well, does this mean that it just outputs to Wayland? Or does this mean that Godot can be a compositor? It's not clear. And how do I know that? Use platform Wayland. I think it means it's a client, but let's look again at the blog post. Native Wayland support EGL. EGL support in turn will also benefit Raspberry Pi handling as one of the big factors. Refactoring of the display and OS code besides working toward native Wayland backends, so be pursuing support for multiple windows with Godot. Okay, right. Yeah, so it is just display. It's not compositing. And I suppose that GStreamer also can do that. I can output into a Wayland sync. Yeah. So that's the thing. So then, what is Simula doing? Is a question, right? Because Simula seems to be doing seems to be a compositor. So what's the architecture actually? There's a demonstration, there's the website. Okay, let's look at the website for a second again. FAQ doesn't really say much. And there's the docs. And there's only some images and serial implementation of motorcar. Needs SteamVR to be running. Definitely using Nix to build that stuff makes a lot of sense. So mouse and keyboard. Windows become active once you look at them. So how is the... Okay, so one possible way in which it would work is that... So it would hook up into the Wayland architecture to somehow, it would need to be a compositor though, I think. But I suppose there's a protocol for that. I wish there was some kind of high-level description of what that does. Let's see, add-ons. Okay, so all the Godot stuff. The Haskell plugin. XR tools. And importing Simula VR environments. Where is the code? Submodules. Okay, the Godot Haskell. Wayland stuff is here as well. Okay. And utils. Some helpers. Okay, what's that? Helpers, links. Okay, well, that was a bit of a distracted kind of overview. Just thinking about what Wayland 3D compositing would be like, and also looking at Simula, and I suppose I should add the link there. And let's see. I want to write something here about generally what I think I might be trying to head towards here. So one thing I'm sure of is that I want to represent things like layer algorithms and things like, I suppose you could call them 3D primitives, but or yeah, 3D primitives, which include things like shapes, symmetries, animations, projections, abstract things. All of these, I want this in Haskell. So layout, that goes into compositing. And so if we have that goes in the direction of actually implementing something like a Wayland compositor in Haskell. But then this is kind of what's happening here, sort of. And so it'd be interesting to know how that's done here. The straightforward way that I would think of it is, yeah, we use WL roots, we build a compositor out of it, so that that compositor can be installed on the Linux desktop, and then it would have maybe you would try to reproduce like a basic well-known desktop environment, but then I don't know how windowing works, by the way. I should learn how does windowing works. How does windowing works? Maybe it's, I suppose maybe it's all the, like right now I'm using, what is it, well, the GNOME desktop, GNOME 3 desktop or whatever. So that's providing all of the windowing widgets. It's just asking the compositor for Windows, I think. So maybe that's okay to start with. Obviously I do want to go further than that, but that's really ambitious. But let's write it still, because you know what, it's ambitious, but so what? Is that how I'd want to describe my actual graphical UI component? All right, Nini. Yeah, it's night for you too. Yeah, it's night for me too. It's a little bit past 10. That sounds good. Yeah, of course. Feel free to stop by again. It was nice to see you. I'm actually probably streaming maybe an hour, not much more, on Saturday. And then after that, I'm taking a 10-day vacation. I'm going to Portugal, super happy about that. And so, yeah, so I won't be streaming during my vacation. But then after that, I'll be remote working. So I'll probably be streaming actually from there. So that'll be sometime like in early June. But yeah, great to meet you, and have a good night of sleep. I'm going to do the same very shortly. And yeah, see you next time. Yeah, how does windowing work? And so layout algorithms is one thing for compositing, and so maybe graphical, like maybe window graphical elements. I mean, that seems like such a huge amount of work. In Haskell, poof, yeah, don't know. Oh yeah, that's all good. Definitely put you on the spot there. But yeah, feel free to just stop by. I'm doing like lots of weird stuff, and always happy to spend some time explaining what I'm up to, and also happy to be interrupted and answer your questions. Yeah, take good care. Yeah, windowing, let's make sure we know that that's ambitious. And it could be that there's actually better, it could be that that's even maybe ambitious / misguided. Because maybe I want this to be themable. So maybe these are themes. So maybe we don't want this in Haskell. That's one of the things that we want to use, something more standard, like maybe HTML, CSS actually, or something slightly better than that. But although that might be slow and whatever, so yeah, something UI. something UI like. Thank you so much. Yes, I will. I will enjoy the sun and the south, and that's going to be amazing. I'm very much looking forward to it. Right, so 3D primitive, that makes sense. And then obviously we kind of, and so if we write this as a stack, then it's kind of like that. Then we have apps and like sort of a, really we have the data layer. And so that's also a Haskell thing. So let's list this as like graphics. And then list this as maybe data. So yeah, there'll be data being provided and it'll be deeply integrated with the 3D primitives. And so apps will be written in whatever, and they'll be, you know, what would they do? They'll instantiate data structures and they'll configure graphical elements, but not much more than that. Oh yeah, well, probably then also maybe they are kind of FFI or an RPC, something like that, right? Yeah. Okay. That has nothing to do with the NBody simulation. That's much broader than that. I'm going to put it somewhere into, let's say 5. Big picture. Okay, but so the fact that we have that gives us a sense though that this is why we're interested in GPU programming here. Is this, there's a kind of graphics and maybe also starting to play with what this means in terms of data structure visualization. Okay. So sure, windowing seems like it might actually be like Wayland composition. Seems like it might be the right thing to piggyback on. But we need to look at it in more details and see how it fit. So clearly, yeah, MacWayface and HSRoot, that would be quite fun to look at. How does this play with this NBody thing? Well, yeah, that's one of the questions is I think I want to know this before I continue here. It is kind of this shared compute workload and data and shared data on the GPU. Is that even possible? Such that, for instance, yeah, for instance, like, and the NBody simulation does compute on the GPU, outputs on a frame, then the frame gets shared with like a Wayland, as a Wayland sync or something. And GStreamer outputs to a Wayland sync, and then the Wayland compositor assembles them, and maybe assembles them but controlled by some data also on the GPU. How about that? That's a whole data flow. And it seems like, as I understand it, Vulkan is able to do this kind of stuff. And we could even add to that, like, also like a sphere v shader outputs to outputs to what? It actually, a sphere v shader could even it could get input from GPU memory and outputs to Wayland sync as well. How about that? I mean, you could, or on wherever, some kind of place to put frames, and then that gets shared. Or maybe what I'm describing is a Vulkan compositor, a Wayland Vulkan compositor. Wayland Vulkan compositor. I'm at the edge. I'm just 5 months late. That's good. I think I've already seen something like that, but soon, work in progress for WR roots. I remember looking into this already. Let's see what I had found in those days. Boom. No results found. So I had not captured this, but apparently it exists. Experimental Wayland compositor, and that's fairly old actually. So, but what's the idea? Explore the possibilities of Vulkan as a rendering backend. Direct scan out of client buffers. Compositing needs to be done. Renders to the screen with simply copy command from Vulkan API. Do the minimal work necessary to display client buffers. Do not need to use screen tearing. Stick to minimal window management features. Try to write simple, easy to understand code. Tries to have minimal dependencies. Wayland server, core server API, protocols to general protocol setters. DRM for controlling the screen, Intel to use Intel buffer management, instead of GBM, Vulkan loader to load appropriate Ventor specific libraries, Ventor specific Vulkan implementation, Mesa for GBM, and EGL, also required by EGL, XKB command for keyboard, LBU dev for GPU discovery, and a hot plugin. Okay. Yeah, so that's not ready. That's just a toy, and that apparently is the state of things. But maybe not. Maybe Vulkan's been included into other things. Wayland book. So it would maybe be through Mesa actually that we'd be getting Vulkan Wayland. What does he say about Mesa here? Pending support pending from extending the ext physical device DRM extension by the likes of the Mesa RadV driver. CTS coverage is a requirement for ext extensions. Just a Mesa extension to bypass that. Okay, let's see if there is a Vulkan allocator. Okay, work in progress draft. Still not done. Okay, I'll subscribe to that. Implement basic Vulkan renderer. Okay, hold on. Current state closed. Superseded. Open. Okay. So I'll follow that as well. That's recent. Maybe it's going wrong. Okay, so that's super bleeding edge. I think it builds on Mesa. And so it means that at some point we might get it. And until then, we can kick the tires of HS roots. Also, I'd like to get a sense of what's the version and what is the Haskell HS root tracking. Well, first of all, it's not even, oh no, there is I'm not in the right place. So what is it, which version is it tracking? It's there's a shell.nix. wr-root.nix. Okay, so that's in nix. And wr-root.nix. Ooh, 0.3. That is old. That is old. That is very old. Very, 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 very old. 2 years old. Okay, not so old. Okay, let's make a note of that. HS roots. So, okay. Okay, so that's, maybe I put this in those questions here. WL Roots is working on a Vulkan backend. And let's put this guy here. Boom. HS Roots depends on 2 years old 0.3 version of WL Roots. Unfortunately. But I mean, okay, let's look at the dependency. Let's see if anyone has actually updated this. Okay, that's a strange, a lot of debug. Okay, what's this? Switch device, fixes. Oh, a lib input. Okay, let's look at this guys. Maybe. Okay, arguably this one is more recent, 2 years ago. 19 commits ahead, 4 commits behind. See. Ah, yes, okay, so that's the one that I was looking at earlier. Okay. So yeah, it's bindings, so it's not pleasant, but maybe we want it. It's mostly not complete, well documented abstracting. Support my own endeavors. Way more not. I should also try to use Wayland. Try to use Wayland on this machine. But I'm also thinking that what I really should do on Saturday is this: prepare for remote streaming. Yeah, I should be packaging things into a hard drive. Yeah, so I'm actually going to just leave it here, and I'll put myself a reminder to be focusing on this for Saturday, because there's a chance that I just jump into code, but I think it will help that this is a bunch of, actually, hold on, what will help is if I also make a note to myself saying something like prepare remote streaming. All right, that's it for me. Thanks a lot for watching. Yeah, it's been Jun-chan, and I see you on Saturday for my last stream before a 10-day break. And yeah, then after that, I'll be streaming from Portugal and working on maybe some PureScript and some of the GStreamer stuff. And so yeah, I'm super excited. See you on Saturday. Bye-bye.